Chapter 6 test review. So taking the derivative of ln of x, e to the fourth, e raised to 4x. So derivative of ln x is just 1 over x. And derivative just plain e raised to just x is e to the x. So if it's something other than x, then I got to take that and times it by the derivative of the exponent. That's only for e raised to something. Dx of 2x. All right, so this one's taking the derivative of e to the fourth. 4x is just e to the 4x, and then times it by the derivative 4x, which is just 4. So 1 over x plus 4e raised to the 4x. Okay, this one, chain rule. So I got to do the derivative of ln, which is just 1 over x. So that'd be 1 over x cubed minus 8, and then I got to times it by the derivative inside, which is just a 3x squared. So it's just the derivative of the inside over the inside. Okay, this next one, again, we already did this one, so this would be 4e to the 4x, and then the derivative of 3x cubed is just 9x squared. Okay, this one, so we have the base, so ln of the base, which is 4, times by what we're taking the log of, over the derivative of what we're taking the log of. Okay. What's the inverse of this? Just switch your x's and y's. So this is going to become x. This is going to become y. Solve. Take the cube root. There's the inverse. Switch that y to f inverse of x. Okay, so there you go. There's the first page. Second page, taking the integral. So this one, just do substitution from 0 to 4. 1 over u dx. U is equal to 3x plus 2. Take the derivative of that, so du equals 3 dx. Divide by 3, replace that. For 1/3 out front. And so we get 1 over u du. Okay. And so then we can go ahead and integrate that. So that'd be the ln of u. And then from 0 to 4, times that by 1/4. So then we can go ahead and plug in 4. So we can plug in 4, and we get whatever that is, minus plugging in, I guess we could just leave that out, it's fine too as well. And then plugging in 0, which doesn't work because I forgot to plug in back my u. My u is 3x plus 2. So this is actually 4 times 3. So 4 times 3 plus 2. And then I take the ln of that, plus 2, and subtract. Plug in 0, so 3 times 0, then plus 2. So that would be 1/4 times ln of 1214 minus ln of 2. So you can plug that in your calculator and get like something close to 0.65. Okay, this one. Here we have another rule when we're taking some base raised to x, and that is 2x over ln of the base, which is 2. And then taking the integral of the x cubed is just adding 1, dividing by whatever that new exponent is. Okay, and then plugging in 4. So 4 and subtract, plugging in 0. Okay, you can type that all in. That'd be distribute that negative, so that's negative as well. 1/4. Then x, which is 0 to the 4th. So that's all 0. That's 1 over ln. 85.6. Okay, this one, really, this is just substitution rule. So, I mean, so you just let u equal x to the 4th plus 5. So du would be 4x cubed dx. So divide by 4. So really it's just a quarter. U cubed x cubed dx. Dx x cubed, right, equals du. So this is just really 1/4 u cubed du. Now I take the integral of u cubed, which is just 1/4 u to the 4th times a 4th. So that's really 1/16. And then I can substitute my u back in, which is x to the 4th plus 5. And then I can, that's to the 4th, and then add c at the end. So there's the answer to that one. I don't know why that one's in there. That was previous chapter anyways. All right, this one. You don't know the integral of this. We do know e to the 4th. E to the 4th is just a constant, so the integral of that is just adding x to it. Then the integral of ln of x, which you don't know, but I'll just give it to you here, is that'd be x ln of x minus x. And that's by integration of parts, which is in the next chapter, but it's in here, and then we can just add c to the end. All right, next one. Substitution, we already know what the integral of e to the 4th is, right? That's just e to the 4th x. And then the integral of ln of x over x, well, we're going to let u equal ln of x. So then the derivative of that would be 1 over x dx, which is exactly what we need if we rewrite this. That'd be u over x dx. So then this gets replaced, right? You can rewrite this as 1 over x u, or backwards, u over 1x. So that equals that, right, which is du. So the integral, let me move that down. Integral of u du is just adding 1 to the exponent and dividing by that. Right, so then we can go ahead and place what u back in there. So 1/2 ln of x, and that's being squared. And then we can add c at then. So there you go for that one. Okay, this one's just solving. So we solve exponentials by taking the ln of both sides when the space e, right? That exponent comes out in front. Ln of e just equals 1. So we just get 3x. Ln of this side is whatever that is. I don't know. Type that in a new calculator. Then we can just divide by 3. So whatever this is in a calculator, there's your answer. Okay, this one, solving this one, we can, since natural log, we can rewrite as an exponent. That'd be base e. E to the answer equals what I'm taking the log of. And e to the 4th, again, is just some number. So I can subtract 2, so I get e to the 4th minus 2, whatever that is, equals e to the negative 2x. Now I can solve this exponential, right, this x as an exponential, by taking the ln of both sides. So that's just going to be some number. Ln of this is just going to turn to negative 2, so I can just divide that by negative 2. So whatever that is in my calculator, I don't know. This last one is the inverse of function or not? Well, this is a quadratic, so it looks like this, right? So if I do the horizontal line test, it tells me that it fails the horizontal line test, which tells me the inverse is not a function. All right, also know how to do, right, the vertical line test tells you if it is a function, right? It passes the vertical, so this is a function, but its inverse fails the horizontal, so its inverse is not a function. Or sorry, this fails the horizontal, so the inverse is not a function. Okay, I also know how to expand logs, right? How to solve logs, how to solve exponentials, those things. There you go.